Welcome back to our math primer. Today we're going to speak about the linear equation, which is a very common task that is encountered across all fields of science, engineering. It's essentially the application of a physical law that leads us to an equation, and today we're going to discuss the linear equations. And of course, in sequence and in due time, we're going to start talking about more complex situations, nonlinear equations and whatnot. But essentially, the task that you're going to be hearing very often is solve for x. This x may be y, z, k, a, b, whatever, but essentially we're going to be solving for an unknown. So let us refresh a couple of things about how we go about solving a linear equation. So in this particular case, it's going to be solve for m. M is our unknown, so we have a fraction here, m minus 2 divided by 3 plus 1, and that is equal to 2 times our unknown m divided by 7. Again, this m can be anything, can be x, b. Little does it matter. All it matters at this point is the least common denominator, right? So we need to arrange these fractions and add them up. And since we got 3 here and a 7 here, the least common denominator is obviously 21. So we're going to multiply both sides, both the numerator and denominator, by 7, so we get the 21 here. This is our goal, so 7 times m minus 2 divided by 21, which is 7 times 3, plus here we have nothing, so we're going to multiply and divide by 21, so 21 by 21. They, of course, fraction does not change. And here, because we have 7 in the denominator, we're going to multiply by 3 both numerator and denominator. So we're going to have 3 times 2, which is 6, divided by 21. Now we're good to go, and we can add our equation. Essentially, we no longer need the fractions here, because 21 can easily go home. Can easily cancel out. Therefore, we have our expression becomes 7 times mass distributive minus 14 plus 21 equals to 6m. And essentially, right now we're going to have in one side of the equation, usually the left, we're going to bring over m, so we get 7m minus 6m. And the same goes for the numbers, so it's going to have 14 minus 21, 14 minus 14, the other side is going to become plus, and negative 21. And all that results into m, our unknown, is 21, 14 minus 21 is minus 7. It's always a good practice to box our result, so we can have it handy. And one thing we can do straight out of the gate is make sure we didn't go wrong anywhere. So this is a common sandwich, as I'd like to call it. So you take your result, 7, and you put it back in the equation, and you go like, okay, did I do this right? So I have to check that indeed negative 7 leads to something that is true, right? So it's going to be negative 7 minus 2 divided by 3 plus 1 equals to 2 times minus 7 divided by 7. And we can see that this leads to the following. This is negative 9 over 3 plus 1, and that is equal to 7 cancels out, and you have negative equals to negative 2. And what do we have here? We have that 9 over 3 is, of course, 3, negative 3, plus 1, negative 2 equals to negative 2. That is good news. Indeed, our solution checks out. So let me make some room on the board. As you know, this is the part where I start erasing things. You can always go back and recheck the video. And now we're going to solve a bit more complex, but the only caveat here, the only possibly problematic point is to make a silly error in terms of algebra. So addition, subtraction, division. Otherwise, these equations are pretty straightforward. So here we have 2 z. Z is our new solve for x unknown, divided by z plus 3. And that is, do I have this right? Yes, equals to 3 divided by z minus 10 plus 2. Now, if you noticed, I have the z with the line in between, so I do not confuse z with 2, right? These are two different things. So it's a good practice to try to separate what is what. In this particular case, we're going to follow the exact same logic. The least common denominator, and in this particular case is z plus 3 times z minus 10, right? So what we do, we multiply whatever needs to be multiplied. The fraction does not change. Here we're going to multiply the numerator with z minus 10. So here it is, times 2z divided by, of course, z plus 3, z minus 10. And that's good. It's going to be equal to, here, the same here, we multiply numerator and denominator by z plus 3 times 3, numerator, and divided by z plus 3, z minus 10. And we also are left with the 2 here, which we're going to multiply both numerator and denominator by the least common denominator, which is z plus 3, z minus 10, divided by z plus 3, z minus 10. So these are not hard problems, these are just elaborate. You have to make sure that you will not forget something when you take all the operations, parentheses and whatnot. Now, please note that we have the left numerator and the right numerator, they have the exact same denominator, right? So if this equation is to hold true, then this numerator must be equal to the numerator to the right. So we don't have any use for all this denominator. So essentially what we can solve for is z minus 10 times 2z equals to z plus 3 times 3 plus 2 times z plus 3, z minus 10. That's all we have to do. So we go here again with the distributive property, and you get, let me change color so it's, you can see that more easily. And what do we have here? We got 2z squared minus 20z equals to, we got 3z plus 9 plus, now here we can do it in one step or we can do it directly. I'm going to do it directly. So in other words, you can do the parentheses first and then the 2, but I think we can manage to do the whole thing at once. So we're going to have 2z squared 2z squared, then we're gonna have, what's next? We're gonna have 2 minus 20, which is this with this. There's no z. To make sure, yes, so it is 2 times z times 10 minus 20z. What's next? We have 2, 3 times z, so that is 6z. And then we finally have 2 times 3 times 10, which is my negative 60. Let's make sure that this algebraic expression is correct. There is no harm in always checking, and this is where I can make a mistake, obviously. 2z squared, this is then 2, 3, 6 minus 60, here it is. 2, 3 times z, that is my 6z, and finally my negative 20, which is this, yeah, I'm sorry, this times this. So I think we're in a good shape. Yep, all right, so the z's with the z's, the numbers with the numbers. Again, we bring everything in one side. However, though, we can easily inspect, we can easily observe that we get a plus 2z here and a plus 2z here, left and right. So yeah, either you're going to bring this over here, you're going to say 2z squared minus this, or you can just cancel them because one is on the left, the other one is on the right hand side. It's pretty obvious that these will cancel, and you're going to be left with negative 20z, minus 3z, plus 20z. Again, this is this, traveling to the left side. And finally we have this, minus 6z. It's going to change the sign, of course. Equals 2. We have no numbers on the left, so it's only here 9 and negative 60, which is negative 51. So what do we have? All the z's together. All the z's together should be 20 cancel out, minus 3 minus 6 minus 9, minus 9z equals minus 51, and your z is finally squeaking 51 over 9, or equal to, if you cancel out by 3, you're going to have 17 over 3. Now again, it is a very good practice to try to place that, to check your solution, put this back in your equation. That's going to be a little bit more elaborate, a few more operations, but it's there. The solution, I checked it, I think is correct. So again, it's a very similar example to the previous one, which is it turns out to be linear equation because again, the second order degree is canceling out, and we're left with just the first order z variable. So nothing to worry about. But again, eventually we're going to deal with second order in the subsequent lectures. Now, what if we have two equations together? That is, for instance, we have a variable x and a variable y or z, whatever. So we have one equation that says x plus, say, 3 equals to 5 minus 5 times y. Now, the close inspection of this should not surprise you. What this is, essentially, it's a linear function. It's a linear function, what we're going to call a new word here. And if you are not familiar with it, that's okay. Essentially, it's a linear function between y and x. Both x and y, their degree is 1, right? So it's a linear function. And it's this equation, which again, it gives you a linear function between y and x, or x and y, which eventually you can at some point plot, right? You can plot this function. And we're going to spend some time how we go about plotting and what these functions look like. Now your second equation is x minus 5 equals to 3y plus 1. So we call this a system of equations. This is my first equation. This is my second equation. We call this a system of equations. And essentially, we have two equations. We got two unknowns. This is not prime. This is 1. Not to be confused. So we got two equations, two unknowns, x and y. And that said, we can choose any path to solve this system of equations. Eventually, our goal is to end up with x equals something, y equals something, right? So how do we go about it? There are different ways. One way that you may be accustomed to is, say you take equation 1 and solve for x, and then you substitute x back in equation 2 and you find y. That's one way to go about it, but there are a few tricks that it's always it's good to have up your sleeve, and you can see that if you were to subtract equation 1 from equation 2, the x's right out the gate will cancel out. So this is what we're going to do, right? Let's see how this is done. So many of my students are surprised when I say, well, we can subtract the two equations. They go like, what? It's essentially the exact same thing as if you were to solve equation 1 for x or y and substitute the other. The exact same thing. So if we subtract this from this, so we're going to get x plus 3. Now we're going to subtract left to left, minus parentheses. Don't be going unaware here. This is all the minus goes for the entire parenthesis. Again, as this minus this equals to the same thing, 5 minus 5y minus 3y plus 1. Okay? So there, essentially in one step, we can solve for, as you're going to find out, for y, because look, the x's will cancel out. Let's take them outside of the parentheses. Minus x, careful, plus 5 here, minus and minus equals to 5 minus 5y minus 3y minus 1. So yes, that was it. That our intention all along was to cancel out the x's. And now we're left with, let's see how many y's. We have negative 8 y's, and we got, so 5 and 5 can also cancel out here, right? So we're going to bring this 1 with the numbers. It's going to be 4. 4 equal to, we have no y's here, we have nothing else, minus 8y. It doesn't really matter, of course, if your unknown is to the right or to the left. That's completely a convention, right? So you can say that y eventually is minus 1/2. That is your solution. And what do? Now you just take your solution of y and put it in to find the x, right? And we can do this by, do I have any space left? I think I can erase some of these here. And I think that should be good. And here we're going to say, well, now I have a solution for y. I'm going to take this equation. It doesn't matter which one, right? It really doesn't matter which one. So you're going to go x plus 3 equals to 5 minus 5. And y, I found it to be negative 1/2, right? And you're going to solve for x, and you're going to find that x, I'm going to skip a few steps here. I'm pretty sure you can do this yourself, is 9/2. So here's my x. So now again, am I right? You always have to question and make sure that you got the right solution. Because if we made a slight mistake somewhere, the entire problem breaks apart. How can we check again? You can choose any equation. Let's say equation 1, and say, well, if x indeed is 9/2, then y is negative 1/2. Let's see if this equation holds. And good news is that it does hold. 9/2 plus 3 equals to 5 minus 5 minus 1/2, I'm sorry. And let's see, do I get this right? I'm sorry, I intended, which equation did I use here? Give me 1 second, 3. So let's see. So we have, here we got 4.5 plus 3 equals to 5 minus, that's going to be plus 5 over 2, 2.5, and what do you get? You get, what is it, 7.5 equals to 7.5. Good news, congratulations, you solved it right. After you become accustomed to solving a lot of these problems, then you build some more confidence that your final result is correct. But always a second and double checking is always recommended. It is very easy, as you can see, to make a mistake because it doesn't take a lot. It's only one mistake that can lead you to a completely different and the wrong result. So it doesn't take much. What if now you have to deal with more than 2 equations, right? 2 equations were pretty simple. You either do a trick, subtract them, add them, or direct substitution. But what if you had a pretty crazy looking scenario? Minus 4x plus 3y plus 3y plus z. That's a 3 equation system equals minus 18.2. The other equation is 5x plus 6y minus 2, z equals to negative 48.8. And finally 2x minus 5y plus 4.5z equals to 92.5. So what if you have this, a 3 by 3, we call the 3 equations, 3 unknowns. 1, 2, 3, that's a linear system. All my unknowns are raised to the power of 1. So again, this is not cube, this is my, I'm enumerating the unknown. So what happens there? Can you solve this by substitution? Yes, of course you can solve it, but it's going to take like double or triple the time that it took us to solve this guy here. So this is where computing and programming, or even your calculator, comes in, and you can do some pretty neat linear algebra, use some pretty neat linear algebra tools on your even calculator, your scientific calculator, or if you know how to program in MATLAB, Python, and the like. So I'm going to put an asterisk here. I'm going to throw a bonus lecture that will show you how to use this in MATLAB, because as a UAH student, the MATLAB is completely free. So I highly suggest that you guys make an account, and you can run MathWorks and MATLAB online. It's pretty neat because I'm going to show you examples from the previous lectures, the preceding lectures, and how we can solve them using MATLAB just by one simple command line. It's really, really handy. So I'm going to stop this video for at this point, and the next one we're going to start diving a little bit into the actual functions, what a function, a physical function, really stands for.